Welcome to the Programming Electronics Academy podcast. Join us every other week as we explore how everyday people are creating extraordinary things in the world. Find us online at programmingelectronics.com.
Hello, I hope you're doing fantastic. This is Michael with Programming Electronics Academy, and if you're a first-time listener, welcome to the show. If you like what you hear, I hope you decide to subscribe. So we started this podcast. What we're trying to do is help educate and inspire you about programming and electronics. We release a new show every other week, ready for your Monday morning routine, whatever that might be. And what you can expect is an interview with somebody who's doing something interesting with technology. Specifically, kind of interested in microcontrollers and development boards like Arduino, because that's kind of the stuff I'm interested in learning more about. This week, I had the pleasure of speaking with Dan from Rheingold Heavy. Dan is an electronics hobbyist, and now he owns his own electronics business, which is pretty cool. We talk about his journey from being kind of an IT guy, then getting into electronics, and ultimately, like I said, starting his own business. We also talk about I2C and SPI communication protocols in the episode. Now, if you think those are names of robots from Star Wars, you're kind of right, but don't sweat it, because Dan is going to do his best to demystify it a little bit in the episode. All right, well, let's go ahead and jump into this week's episode. So, Dan, we've known each other for probably going on 2 years now. I can't believe it's been that long.
Yeah.
But if you wouldn't mind, could you kind of walk us through your journey into how you got into electronics and really designing electronics and starting your own company there?
Sure. So, my interest in electronics really started decades ago at this point. I'd say it was probably late 90s, early 2000s. I had a job in Silicon Valley, and I was doing IT work. I was actually an IT director for a startup out there. And one of the things that I discovered is that there's this sort of this tier of nerddom in Silicon Valley. And, I was a Windows guy. I was managing a Windows network. And so I was bottom of the rung, like lowest on the totem pole, the least technical of the technical fields. Right. But at the upper level, at the highest part of the totem pole were the hardware engineers, like the guys that were dealing with silicon and were designing circuits and making circuit boards. And that stuff was fascinating to me, absolutely fascinating to me. And I'd never really dealt with it before. So I wound up, scouring a bunch of bookstores and going to sort of surplus electronics places and sort of putting together my own sort of component library, and started, with Forrest Mims guides on basic circuits and stuff like that. And slowly started to teach myself electronics while all at the same time managing, a Windows enterprise, which was probably one of the duller aspects of it. And, time passed. I wound up going to Mission College down in up in Santa Clara for a couple semesters, because I never went to university, so I don't have a degree. But I thought it would be helpful to start, sort of building up towards that. And I thought, well, maybe I'll have the time. I can go to night school or something like that and work towards a double E. But unfortunately, life gets in the way. I got laid off from that company and wound up actually moving to Los Angeles, which is where I am now. And while I was down here, I was working again in IT and for an investment bank of all things. So very, very little need at all for electronics. And honestly, sort of back then, YouTube didn't exist. The internet was still, web rings and spinning GIFs. It really wasn't the resource that I certainly expect on a daily basis now. So teaching the electronics to myself in sort of the limited time that I had every day was really difficult. And it, today, if you go to search something out and you don't like the way it's being taught to you by one resource, you just click over the browser tab and you've got a different tone, you've got a different point of view, you've got a different way of approaching a topic that maybe works better for you than the other one did. But back then it was just a matter of, the Practical Inventor's Guide to Electronics and Forrest Mims guides and maybe a handful of other things. And it never really clicked for me, which was really frustrating. But I dutifully carried this big box of passive components everywhere I went, and maybe once or twice a year I'd get the bug and I'd put a blinky LED together or something like that, but never really advanced with it until I started listening to the Amp Hour, which is Chris Gammell's podcast. And somehow, some way, the way they were talking about it, they completely demystified it for me. And it's not like that podcast is going out of its way to teach electronics, but it convinced me that it was not outside the realm of possibility for me to be able to learn this stuff, that it didn't require necessarily going to get a double E degree to be able to do the things that I wanted to do, which is, I'm not looking to build, design a gigabit router from scratch. I just want to be able to, automate a coffee maker or something like that when I feel like it. So I started getting, getting the components out and playing around in my spare time, which I didn't really have much of at the time, but like I had that burning desire that to really prove to myself that I could figure this stuff out. And I think one of the things that really helped is that I had really struggled with the concept of amplifiers and how transistors could be used to amplify something. And I'd kind of worked it out in my head, but I hadn't found any way of or any resource that actually described it to me the way that I thought it would work. And I'd stumbled across some web page finally somewhere that basically said that the way I had been thinking about it was correct. And that was this sort of moment of validation that that this stuff is in fact something that I can figure out, not just from what I read, but based on the things that I have learned. I can sort of make intellectual leaps in understanding how other aspects of the subject work without necessarily having to go and research it for myself, if that makes sense.
Yeah, it does.
So I really started to progress fast. And then, I had I think I had a basic stamp at one point, a PIC microcontroller. And at some point I got something called a nerd kit, I think, that I never really did anything with. But microcontrollers really hadn't hit for me. And, even though I was in IT, like I said, I was more on the administrative side of managing the people that manage the network, rather than, writing my own code. So microcontrollers really hadn't been too approachable. And then, like I would imagine a lot of people, an Arduino plopped in my lap, and I was just, it was such an enabling technology, so easy to approach, that, it just opened up this entire world of being able to take all the sort of analog stuff that I'd been doing to that point and combining it with all this wide realm of digital microcontroller and embedded aspects, that was just absolutely incredible. And then sort of the final step was taking the contextual electronics class from Chris Gammell and finally starting to make my own circuit boards. And then, I had a decent library of stuff of my own that I'd either built on breadboards or built on perf board, and sort of a library of my own sort of, cocktail napkin doodle schematics, that I could now literally turn into actual real circuit boards at a remarkably reasonable cost. And then at that point, I got laid off again. So this was a couple of years ago. I got let go from my employer back then, and I thought, well, I think I've spent 20 years in IT. I think that's enough time in the trenches for anybody. Why don't I see if I can make a go at trying to sell, just trying to sell something of my own. Maybe I can make a circuit board that would be interesting, that would be compelling, that would be helpful for other people. And what I really did was I gave myself the opportunity to fail. I kept telling myself, like, look, you're gonna come up with an idea, but if you don't come up with an idea, that's perfectly fine. And if you don't come up with an idea, get another job in IT. Well, I came up with an idea. And then I said, well, okay, design the circuit. But if the circuit doesn't work, that's totally okay. But I designed the circuit and the circuit worked. And then I thought, okay, well, now I'll get the board made. But the board's not going to work. So if the board doesn't work, and, you go through these sorts of, I kept setting these sort of benchmarks for myself. And it was okay if I hit the benchmark and nothing worked, because I always had this out to, just go back to the way things were. But every time I got to one of those benchmarks, it always worked. And then sort of the big one was, well, let's see if anybody actually wants to buy this. So I started a Kickstarter, and turns out, end of the Kickstarter, the thing sold twice as many as I had planned to. So, that sort of got me started down the road of starting my own electronics company.
So what is the board? I know you've been talking about the board. Can you tell us a little bit about it?
Sure. So that the board that I developed for the Kickstarter was the I2C and SPI or SPI education shield. And the idea behind it was that I had personally struggled trying to understand not just how to make a library work, but to really understand how I2C and SPI as serial protocols worked. And I'm the sort of guy that hates using libraries if I can possibly avoid it. I don't like using other people's code if I don't understand how that code works. So, now admittedly, if you're using an Arduino, you're probably you're not bit banging I2C yourself. You're probably using the wire library. You're using the SPI library to do your work. But I mean, it's sort of part of the IDE. It comes prepackaged with it. So, I'm kind of fine doing that. But downloading like a library that's designed to work specifically with a chip that has hidden all the registers behind sort of cute variable names, that doesn't work for me. I got to know what it is that I'm interfacing with. I want to know which registers I'm writing to, which bits I'm flipping. I want to be able to match what I'm reading in the data sheet with what I'm actually writing code for. So consequently, I had to understand how I2C and SPI worked, and there were really few resources to tell me that. So I realized, sort of if you want to sell a product, find a problem and fix it. And I thought, well, I can't have been the only person to have struggled learning this. So why not make a system that makes it very easy and very approachable for people to learn these really, really, really important technologies. So I designed a board that walks you from the very basics of what a clock signal is, what a data signal is, and what a latch is, and why all three need to work in unison, from literally a mechanical aspect, because you press buttons to make those things happen, all the way through the basics of I2C, through advanced I2C, to the basics of SPI, to advanced SPI, and then wrote a whole bunch of content to go with it.
That's really cool. So I2C and SPI kind of sounds like, I mean, it could be the name of a Star Wars robot if you add PO on the end. So would you mind kind of elaborating on both of those a little bit?
Sure.
And just pretend that I don't know anything about them. Just pretend.
You're asking for a friend, right?
That's right.
So SPI is SPI and stands for Serial Peripheral Interface. And I2C is, and it's been a while since I looked this up, it is, I believe, integrated circuit. And the end result of both of these is to allow one chip to communicate with another chip. That's really basically it. For the most part, you're talking about a microcontroller like an Atmega 328P that's on the Arduino, talking to a sensor, for example. And these are very, very standardized protocols that allow you to do this in very efficient ways. That's basically what I2C and SPI are. They accomplish basically the same thing, but they approach it from different angles.
So these are protocols you would find everywhere on all different types of chips.
You will find if you look at pretty much any microcontroller, and it doesn't matter if it is the Atmega 328P, just like fresh from the foundry, stamped with Atmel, or you're looking at the Arduino, or you're looking at a PIC microcontroller, or you're looking at some crazy advanced microcontroller from some super secret society. It doesn't really matter. When you look at the data sheet and it'll talk about what the various pins do, all of those microcontrollers will always have at least one I2C bus on there and one SPI bus. And for I2C, you need 2 pins. And for SPI, you need a minimum of 3 pins.
And so when you say bus, you're just talking about a group of pins together.
Exactly. The system, the communications system is
Gotcha.
the bus.
And what makes those pins different than like just a regular input-output pin?
Because they've got built into the silicon a way of executing those protocols in very specific, I was going to say time signatures, but that's music. They have ways in the silicon of manipulating those pins at very specific clock frequencies. So it's not a matter of, like, if you're thinking about an Arduino and you want to send out a very specific pulse at 1 hertz, that means that and I'm going to screw up this math now, every 500 milliseconds your digital write high, and every 500 milliseconds you digital write low, right? So once a second the pin's going high and then the pin's going low.
Right. And
I think that might actually not be 1 hertz. But I've spent a lot of time around milling machines recently. My electronics is sort of isn't as fresh as it was maybe 3 months ago.
It's perfectly fine because live math is the devil. So it sounds like if you can get a grasp of like I2C and SPI, then it can kind of broaden your horizons a little bit because it's just really common. You can apply it in a lot of different places.
I mean, it's not just common; it is absolutely ubiquitous. If you go and start looking at the world of sensors that exist, everything from the simplest temperature sensor up to these really, really crazy advanced MEMS technology accelerometers, they all speak I2C and SPI. Now, some of them speak only I2C, some of them only speak SPI, some of them speak either, and then they have different ways of configuring the chip to allow you to use one or the other. And there are obviously other technologies as well, like that. UART, just basic serial, is one method. There's CAN bus. There's different technologies, but I2C and SPI are by far the ones that you'll run across the most.
So when somebody's learning the I2C and SPI, what do you feel like is one of the biggest challenges for them that you were trying to help with when you made your shield? And your board, the board we've been talking about, the I2C and SPI or SPI education shield, it is a shield, right? It fits on top of the Arduino. Is that correct?
Exactly. It's deliberately intended to work with the Arduino.
Gotcha. And so I'm just curious, were there certain aspects of that you were really trying to nail because you knew it was, you felt like it was a extremely difficult part to understand?
Well, there were a couple things. First, troubleshooting. If it doesn't work right, you're gonna have to learn it, because you can't troubleshoot these things without having sort of the broader understanding of how they work. If you can't figure out that you're not getting an acknowledgement from your I2C slave, then if you can't at least do that, then you're never going to have any idea whether or not your chip is responding at all. If you don't know, which pin to check on a sensor that's using SPI to see whether you're taking its chip select high or low at the appropriate time, you've got no way of really troubleshooting the SPI bus in that case. And sure enough, the first chip that I tried using with SPI was I think it was a 12-bit digital to analog converter. So anybody that uses an Arduino has probably used the analog pins on there, and those are analog to digital converters. So they take some voltage between 0 and 5 volts, and they tell you that it is some number between 0 and, is it 1024?
Yep.
1024, right? So you're taking some analog voltage and you're converting it into a digital value. Well, the DAC, the digital to analog converter, just does the exact opposite. You tell it some value between 0 and 1024, and it converts that back into a DC voltage. So I was trying to use one of these things, but it wasn't 8 bits. It was 12 bits. And I'm like, well, that's 4 more than 8. That much math I can do live. But the problem is that nothing inside the SPI bus is 12 bits. It's all 8 bits. So I was really struggling to understand how I can communicate how can I read back only 12 bits? If I can only get back 8-bit chunks, that would mean I could only read back 16 bits. So, how do I not read those extra 4 bits? Am I just going to get junk? And so, in this case, I was working with a chip that didn't have some sort of convenient to download library, because I don't like doing anything easy. So I had to figure out why this wasn't working. Was it in my code, or was it because of the way I designed the circuit that was on the circuit board that I'd gotten back from Osh Park? So that was sort of the origin of it, was me trying to figure out why that particular chip wasn't working. And the resources that I was able to find online, because this wasn't like one of those really common chips that everybody talks about on the Arduino forum, it was a matter of, well, you have to figure this stuff out yourself, man. Like the sort of like SPI basics or the I2C basics tutorials, just like they leapt straight to sort of like college level discussions about how to use it. It wasn't that sort of like practical, let's start from the basics and work our way up. So that was the origin. That was the challenge that I was facing, and why I started working on that as a system that I thought people would be interested in.
And just to kind of speak to, the system that you've worked on, the Shield, I feel like it's not just the Shield, and I think you'd agree with me here, but it's the Shield and all the documentation and the learning material that you've kind of created to go with it. And if anybody's listening to this and this is piqued their interest, you can check all of the stuff that he's written. All the stuff that Dan's written about the board is on his website at Rheingold Heavy, and it really is just well written. It's written in a language that is comfortable to read, casual to read, I guess is the word. It's got some humor in there, so it makes it fun. And they're not like super long lessons. I feel like they're kind of nice chunks of data to work through. So it's absolutely a great resource, having looked through it myself quite a bit. So
thank you.
It's it's cool that you've got it out there like that. Just anybody can check it out. So Dan, I know you probably more than a lot of the listeners. Of course, I don't know who's listening, but
my dad's listening.
So I know that you're passionate about educating people who are interested in electronics and willing to put in work and stuff like that. So I'm curious, other people out there who are also interested in educating, any advice you would give them when they're working with people who are just getting into electronics? Oh,
absolutely. I mean, if you're teaching anything technical, you got to have patience. And I mean, if you're dealing with a younger audience, they are sort of by default going to be more comfortable with the material that you're presenting. And they are not as scared about breaking something. However, when you're dealing with adults and people that are coming to a technological topic from the cold, they are definitely of the standpoint of worrying about the sort of you break it, you bought it standpoint. Like, if I press the wrong thing, I'm going to blow it up and then it won't work. And then not only will I not be able to do it, but I'll never understand why it doesn't work anymore. Like, why did my computer crash? I've got no idea. I just got a blue screen of death that's got a whole bunch of memory registers on there. Like, it doesn't tell me anything. And I haven't learned anything. And now my system just doesn't work anymore. So you have to be really patient. I always like using that phrase demystify, because people think that there is something to technology that they just can't grasp. And I mean, there are some people, sure, that just, I'm not going to say can't grasp, but I'm saying that it's not, they just don't care. They don't want to learn. And that's fine. Like, I'm not going to convince everybody in the world that they got to learn how to write, embedded software. I'm not going to convince everybody that they got to know, why it is that that an RGB LED strip can change color. Some people just like pretty lights, and that is totally cool. But if you're the sort of person that wants to know it, I want to make sure that I am tearing down the barriers that would possibly intimidate you from learning it in the first place. Because that's what frustrates me, is when somebody thinks that there are barriers that have been deliberately put in their way to be able to learn something. That's probably one of the most offensive things I can think about. So being able to focus on being patient with someone and coming from the standpoint of demystifying something by breaking it down into easily understood parts, I think is probably the key to teaching a technical topic to somebody that's inexperienced in the particular field that you're presenting.
That's fantastic. Those are great points. And I'm curious what your thoughts are, but I know for me, I feel like one of the ways I've learned the most is when I am actively teaching.
Yeah, absolutely. And that's one of the reasons. So I just taught an introduction to CNC fabrication class. And one of the reasons I wanted to teach that is not because I am any kind of expert in CNC fabrication, but because I know for a fact that the act of putting that curriculum together and trying to be prepared for questions that the students are going to ask is going to make me better at the topic overall. And then the questions that the students do wind up asking are just going to help expose the areas where I need to either improve my curriculum or improve my basic understanding of the subject matter. But I made absolutely clear to the students that take the class that I'm not Bob Warfield CNC cookbook G Wizard master. I'm not a master machinist. I'm not even a journeyman machinist. I'm not even an apprentice machinist. I'm just a dude with a CNC mill. But I am here to give you the benefit of the mistakes that I've already made. So hopefully I can sort of shorten your path to it.
Well, hey, let's leave it at that. I really appreciate, Dan, you taking the time to come and talk. And it was interesting to learn about kind of the journey you've been on and I2C and SPI Shield that you worked on. So that's
Sure.
Exciting. Thanks, Dan.
Absolutely. Thanks for having me on, Michael. I appreciate it.
You bet. Well, I hope you enjoyed our discussion. Got a little technical in there. If you felt like it was over your head, that can be a good thing. Helps stretch you a little bit. If you want to follow up with some of the concepts that we talked about, you can go to the show notes for this episode at programmingelectronics.com. Just go to the podcast tab and find the show. I'll make sure to link specifically to Dan's website and the great resource that he's provided online for learning about I2C and SPI. I just want to say thanks a ton for listening. Much appreciated. If you enjoyed the show, I would love if you could subscribe, rate, review the show on iTunes. Kind of helps us on our journey to take over the world. And hey, listen, if you're at a point where you're getting into electronics and programming, maybe you've been doing it a while and you just feel overwhelmed, feel like everything's kind of crazy, don't sweat it. Before you know it, you'll be building circuit boards while you're barefoot skiing or something. All right, hey, can't wait to see you in the next show. Take it easy. Bye.
This show is produced by Programming Electronics Academy, an online technology education company. We exist to help you create the technology you want in your life. If you are interested in learning more about Arduino, we welcome you to sign up for our free Arduino Crash Course, a 12-part video series with accompanying written lessons designed to teach the basics of programming Arduino. To register for the course, simply text your email address to 440-701-5311, or you can visit programmingelectronics.com and sign up there.